Hi all. In this video, let's take an illustrative example to find minimum in a list. What is list? List is a collection of elements of different data types. Data is nothing but the input that we receive from the user, which can be integer or floating point number or any other data type. In chapter 2, we will be discussing in detail about data types. The question here is, we have to find minimum element among the elements present in the list. For that, I am going to consider totally 6 elements. I am getting the input as 6. The total elements, I am storing it in the name n. Next, I am going to take those 6 numbers. So you can see those 6 numbers are 3, 2, 5, 7, 1 and the last number I have received as 4. So I am going to find minimum number from all these 6 numbers. So what logic can I apply to find it? So the logic here is, first I am going to take the first element as minimum. So initially I am going to consider the first element in the list as the minimum number. Then I am going to compare with the remaining other elements from the list. So during comparing, if I find any other elements is smaller than this particular number, then I will consider that value as minimum. So this is the logic behind this, and let's see its comparison. You can see I have taken the first number in the list, that is 3, and I am considering that as minimum initially. Next, I am going to compare with the remaining other elements in the list. First, I am comparing it with 2. When I compare 3 and 2, I found 2 to be minimum than 3. So I am replacing the minimum number from 3 to 2. So the minimum number now is 2. Next, I am going to compare 2 with 5. When I compare it, I still found 2 is the minimum, so there is no change. Next, I just compare 2 and 7. And no change, still minimum number is 2 over here. The next element in the list is 1. Here I am comparing the minimum element 2 with 1 and I found 1 to be smaller than 2. So here I am replacing the minimum number from 2 to 1. Finally, I am taking the last element in the list, that is 4, and I am comparing with the minimum number 1 and I found 1 to be the minimum with the 4. So finally there is no change, so the minimum number in the list remains 1. Let's write an algorithm for this logic. Step 1. Start. Step 2. Read the total number of elements in the name n. Step 3. Set I is equal to 0. So this will be used to access all the elements from the list. Step 4. Read the first element from the list and consider it as min, which means minimum. Step 5. While I less than n minus 1, repeat the step from 6 to 8. So this helps to access all the elements starting from 0 till n minus 1. Step 6. Read the next number as num, and in step 7 I am going to consider that number is less than minimum. If condition gets true, I will be taking that number as min. So set min is equal to num. 8th step, I am setting I is equal to I plus 1 to access the next element from the list. So finally 6 to 8 will be keep on executing until I less than n minus 1. Finally, after all the comparison, we will go to step 9, print the minimum and end. Now let's convert the algorithm into pseudocode. Pseudocode is an high-level description of an algorithm. Hope you remember the rules for writing pseudocode. If not, kindly watch the pseudocode video in this chapter. You can see we have completely translated the algorithm into pseudocode. We have capitalized the keywords and proper indentation has been applied. The flow of logic is same as that of the algorithm. We have read the numbers in n, set I is equal to 0. We have read the first element as min. In while we have given the condition, so this while is used to take all the elements from the list and compare it and find the minimum element. So here in the condition, you can give it even I less than or equal to n and set I is equal to 1. So if you set I is equal to 0, you have to give the condition as I less than n minus 1. Say if you set I is equal to 1, you can set the condition, you can fill the condition as I less than or equal to n. Both the ways are correct. So in both the conditions, the while block, the statements within the while block will be executed for 5 times, which means for a total of 6 elements, the comparison will be taken for 5 times to find the minimum element. So within the while block, we have read the next elements, compared it with the minimum element. If we found that num as minimum, then we set minimum equal to num. So for each time, the I will be incremented. So starting from 0, it will keep on incrementing for the condition. So if the condition I have mentioned as I less than n minus 1, then it will each time it starts from 0 less than 5, then 1 less than 5, 2 less than 5, it keeps on going till 4 less than 5, which means it will execute for 5 times. Finally, the minimum element will get printed and we can end the pseudocode. Similarly, let's design a flowchart for this logic. We have to use appropriate symbol for each flow. So initially start it, read the numbers. For reading or printing, we have to use the parallelogram. So you can see we have used the parallelogram to read number of elements as n and set I is equal to 0. So if you initialize or if you perform any process, you have to use this rectangle which is called as a process symbol. Next I am reading the first element as min. So I am reading, so I am using the parallelogram. Here I am going to check the condition. So if the condition gets true, I am going to keep on executing. That is, I am going to take all the elements from the list and I am going to process it and find the minimum. So here I am used the decision symbol, the diamond symbol, and I have given the logic within that. So the condition inside the decision is I less than n minus 1. So if the condition gets true, I am going to read the next number and inside that I am going to check further if the given number is minimum or not. So inner decision has been done. So I am using a diamond symbol over there again to make a decision. So if S, I am going to set the minimum number equal to num. Say if no, I am going to access the next number from the list. For that I am going to give set I is equal to I plus 1. So this will keep on continuing until all the elements from the list are being accessed. So once all the elements are being compared, so the decision symbol is I less than n minus 1. The condition becomes fail. Then here just the output is being printed and finally I stop the flowchart. The output printed over here is the minimum element in the list. So this video would have helped to find the minimum element in the list and develop the same in algorithm, flowchart and pseudocode. Similarly, you can try to solve it to find the maximum number in the list.